Right, today we're working on rational exponents, which essentially is the exponent will be a fraction, and of course the denominator is the index. We've been through that a little bit. We're setting up to be able to solve some algebraic equations where the variable is in the exponent, setting up for logarithms, a really important skill set. So we start out with basic numbers, and we start breaking those into bases with powers, and it all goes from there. So let's begin. I'm just going to do a whole bunch of problems and let you guys do the odd ones along in this section. So here we go. 125. I'm going to break that up as 5 times 5 times 5, 25 times 5. That's 5 to the third. Like I said, the more you do the cubes, the better you get at it. So this would turn out to be 5 to the third for the 125. I put that in parentheses because I'm only working with the 125, not the 1/3 power yet. Now, we can use this rule. Power to a power, you multiply. And when you multiply 3 times 1/3, that just equals 5. So 125 to the 1/3 power is 5. And that's how we calculate these without needing a machine. All right? Most of the ones we start out here will be integer answers because we're trying to get the concept down. And you can start to see what's going to happen. Now, of course, it's a square root. We've known that, so this answer is 7. We'll write it out. That's 7 to the second power to the 1/2. 7 to the 1 whole. 2 over 2. I won't write that part again. I'm just showing you where it comes from. All right. Next we would have, let's see, -3 to the 1/3. -3 to the 1/3. -3 to the 1/3. Here we are multiplying, and we multiply with the same base. We add the exponents. These all have the same base. It is multiplied together, so then we add the exponents. All 3/3, so it's -3 to the 3/3. Notice I'm not doing anything to the base. I'm keeping that the same, and I'm adding the exponents, and then we calculate after that. -3 to the first is just -3. Let's see, 2 to the 1/2 times 32 to the 1/2. Now, as these both have the same power, there's a couple ways to go about doing this. This is 2 to the 5th. 2 to the 5th and 2 to the 1st, add them up, 2 to the 6th, divided by 2, 2 to the 3rd. This would be 8. We're going to go a little bit of a different approach here, using the rules here, kind of backwards. We have the same exponent. So it's almost this rule backwards. We have the same exponent. So we're going to pull that exponent out, and we have 2 times 32. Both of those have the 1/2 power. This cannot be done when it's addition. This has to be a multiplication problem. So you notice all these problems in this section are multiplication. There's not addition signs. This is 64 to the 1/2 power. That, of course, is 8 to the second to the 1/2 power. Notice I didn't change the 1/2. I was dealing with the 64, changing that, not the power, outside. And then multiply. 2 times 1/2 is 2 over 2, or 8 to the first. Just 8. Three to the 1/4. 27 to the 1/4. Now, of course, as you get better at this, you'll be able to do some calculations as follows. And some of you will be able to follow exactly what I'm going to say. And then I'll certainly do the problem at using some exponents. That's 81. And 81 is 9 times 9, which is 3 times 3 times 3 times 3. So this is going to be 3 as my final answer, the 4th root of 81. All right, we shall prove that. That's 3 to the 1/4 times, that's 3 to the 3rd. To the 1/4. Notice I didn't change anything but the 27 to 3 to the 3rd. Okay? I have the same bases, but exponents are done before multiplication. So this part has to be done first. That's equal to 3 to the 1/4 times 3 to the 3/4. when you multiply with the same base, we're back to this rule. Same base, they both got 3. Add the exponents. 1/4 and 3/4 is 4/4. 3 to the first. This should seem a little familiar, as these rules were indeed done in Algebra 1. We're just going to step it up a little bit with how we solve equations using this. So this is a bit of a review from some good Algebra 1. All right, radical form. So the next set of instructions for putting radical form, x to the 1/5. And that's simply going to be, your denominator is your index, and your numerator is your power of your base. That's it. So there's a few of those to do. We'll just write them all down at once, I guess. We have y to the 2/5. And I'll put the answer set underneath. We have t to the -3/4. And then we have y to the 1.2. Now for the 1.2 part, you will need to know a little bit of fractions. I'll talk about how we change that back over when we get to that. All right, let's start out with simple. The index goes outside, and inside goes the base and its power. That's pretty much it. Same thing, except we have a negative. When we have a negative, we're just going to put our answer on the opposite side of where it exists presently. Presently, it's a fraction like so. What'll happen is this will just flip. So I'll have 1 over the index is 4, and the power of the base is 3. And then here, you just need to know what 1.2 is. 0.2 is 1/5. So this, essentially, is 1 1/5. Now, 1 1/5, of course, we multiply. 5 plus 1 is 6. That's equal to y to the 6/5. So in radical form, now, of course, we could break this up as y to the first, y to the 5/5, times y to the 1/5. Using these skills, these exact rules, forwards and backwards here. So now we have this part to be radical and this part to be just a whole base. So we have y to the first power, and then inside would be the 5th root of y. Now, fair warning for this one section with the author. I did scan through how they set the problems up here, and simple as radical form is what you see me do here. That's a matter of habit. However, the answer for this, another acceptable answer for y to the 6/5, as far as the textbook places an answer, would be the 5th root of y to the 6. But as we stated previously, it's never as simple as radical form if the power inside, the power of the radicand, is larger than the index. If it is, we divide it, and that's what you saw me doing here. All right, that's putting it from exponent form into radical form. And that set of problems is simply working that same procedure backwards. And we would have the square root of 7x to the 3rd. This would be number 28. The 30 would be the square root of 7x to the 3rd. Well, for space purposes, we'll just do one more in here. The 3rd root of a to the 2nd. Okay, what we essentially have is this cleverly hidden, where this part needs to be in a quantity. So all of it is raised to the 1/2 power, each of them. So each base is treated separately. And that's it. In exponent form, that indeed would be it. You don't need the parentheses when you have a number, a coefficient that's an integer, or any number in front of a variable. You don't need the times, of course, or the quantity to show the multiplication. It's applied multiplication. That's pretty much it. Don't overthink this. That's your denominator, that's your numerator, that's your denominator. That's how it works, numerator, denominator. So what we have here is a 1/2 power. This is a power to a power cleverly hidden. So when we write this part, 1/2, 1/2. So 7 to the 1/2, x to the 1/2, that's being raised to the third power. Notice I did not deal with the 3 yet. I'm getting rid of the radical because the point is to write it in exponent form without the radical. Power to a power, we multiply. That's this rule. This rule, same rule actually. You multiply 1 times n times n. 1/2 times 3. 1/2 times 3. And that's in exponent form. A, 1/3. And then raise it to the second power. 2 times 1/3. When you multiply across the top and across the bottom. 1 times 2 and 3 times 1.